Welcome viewers, in today's video we will deep dive into the interesting world of aircraft windows. Have you ever noticed that aircraft windows are much smaller than the windows in buses, trains or buildings? There is a very important safety reason behind this unique design. Aircraft windows may look simple, but they are among the most carefully engineered parts of an airplane. They are carefully engineered to withstand extreme pressure differences during flight. When an aircraft climbs to cruising altitude, usually around 35,000 feet, the outside air pressure becomes extremely low, and where the outside temperature can fall below minus 50 degrees Celsius. However, passengers inside the cabin need a comfortable breathing environment, so the cabin is pressurized for conditions at few thousands of feet. This creates a huge pressure difference between the inside and outside of the aircraft. Every part of the fuselage, including the windows, experiences enormous stress every time an aircraft flies at high altitude. These windows protect passengers from extreme cold, low pressure, and powerful aerodynamic forces while still allowing people to enjoy breathtaking views from the sky. Aircraft windows play a major role in maintaining cabin safety and passenger comfort during these extreme conditions. Do you know why aircraft windows are rounded in the corners and small? In the early days of jet aviation during the 1950s, some aircraft were designed with square windows. Aircraft windows were not as advanced as they are today. It was later discovered that square corners created stress concentration points, leading to cracks and structural failures. This discovery completely changed aircraft window design forever. Tiny cracks formed at the sharp edges and expanded rapidly under repeated pressurization cycles. This problem contributed to serious accidents involving the famous de Havilland Comet aircraft in 1950s. After extensive investigations, engineers redesigned aircraft windows with rounded corners. Rounded shapes distribute stress evenly across the surface and greatly reduce the risk of structural cracking. That is why almost every modern passenger aircraft today uses oval or rounded windows. Rounded windows distribute stress more evenly across the surface, greatly reducing the risk of structural failure. Aircraft windows are also intentionally kept small. Larger windows would weaken the aircraft fuselage and increase structural stress. Smaller windows improve overall aircraft strength while still providing passengers with outside visibility. By keeping windows compact, engineers ensure better pressure resistance while maintaining passenger visibility and safety. Modern aircraft windows are small, rounded, extremely strong, and built using advanced aerospace materials. They are tested under severe pressure cycles, impact conditions, and temperature extremes to ensure passenger safety on every flight. Although passengers mainly use windows to enjoy cloud views, aviation engineers see them as critical structural safety components that must perform flawlessly throughout thousands of flights. So, the next time you look out of an airplane window, remember that its small rounded shape is the result of decades of aerospace engineering and hard-learned aviation lessons. 2. Composition of aircraft windows. Most passengers think airplane windows are made of a single sheet of glass, but aircraft windows are actually made of multiple layers of specially engineered acrylic materials. A typical commercial aircraft window usually contains 3 panes. Each layer serves a different purpose in maintaining safety and passenger comfort. Outer pane. The outer pane is the strongest and most important layer. It carries most of the cabin pressure load during flight. Since cabin pressure inside the aircraft is much higher than the outside atmospheric pressure at cruising altitude, this pane is designed to endure extreme stress, temperature changes, and high altitude conditions. Middle pane. The middle pane acts as a backup safety layer. If the outer pane becomes damaged or cracked, The middle pane provides additional structural support and helps maintain cabin integrity and prevent cabin inner pane. The inner pane is the part passengers can touch, is mainly a protective layer. Its main purpose is to protect the structural layers from scratches, accidental damage, and passenger contact. Aircraft windows are not made from ordinary household glass. Instead, aerospace-grade stretched acrylic materials are commonly used because they are lighter, stronger, and more resistant to pressure variations than normal glass. Modern aircraft windows also contain coatings that reduce ultraviolet radiation and solar heat entering the cabin, improving passenger comfort during long flights. Modern aircraft windows may also include UV protective coatings and heat-reducing materials to improve passenger comfort during long flights. 3. Advanced technologies in modern aircraft. Windows aircraft window technology has evolved significantly over the years. Modern aircraft manufacturers are continuously introducing innovations to improve passenger experience and operational efficiency. One of the best examples is the Boeing 787 Dreamliner. Instead of traditional pull-down window shades, the aircraft uses electronically dimmable windows. Passengers can darken the windows using electronic controls. These windows use electrochromic technology that changes the transparency of the window when electrical current is applied. This system reduces cabin heat, improves passenger comfort, and allows airlines to create a more pleasant cabin environment during long-haul flights. Aircraft windows are also tested under highly demanding conditions before receiving certification approval. Engineers conduct repeated pressure cycle tests to simulate thousands of flights. Windows are exposed to extreme cold, heat, impact tests, and even lightning strike simulations. These extensive tests ensure that aircraft windows remain reliable throughout the aircraft's operational life. The design of aircraft windows is entirely based on safety and structural efficiency. Aircraft window designs are continuously improved using advanced computer simulations, pressure testing, and aerodynamic studies to ensure maximum safety and efficiency.
Interesting facts about aircraft windows. Aircraft windows may appear simple, but they include many hidden safety features and fascinating engineering details. Aircraft windows contain many fascinating engineering details that most passengers never notice. At cruising altitude, outside temperatures can drop below -50 degrees Celsius. Despite these freezing conditions, aircraft windows help maintain a comfortable cabin environment for passengers. Modern aircraft windows are generally classified into cockpit windows, cabin passenger windows, emergency exit windows, and observation windows. Many passengers notice frost forming around the edges of windows during flight. This occurs because the outer pane becomes extremely cold while the cabin remains warm. Aircraft windows are also carefully aligned with the fuselage structure to minimize aerodynamic drag. Even small design changes can affect fuel efficiency and aircraft performance. Emergency exit windows are specially designed for rapid evacuation. These windows must be lightweight enough for passengers or crew members to remove quickly during emergencies, while still maintaining structural strength during normal operations. Emergency exit windows are specially engineered to be removable during evacuations while still remaining structurally secure during flight. Some military aircraft and private jets use advanced multi-layer transparent materials capable of withstanding much higher impact forces than standard passenger aircraft windows. Cockpit windows are even more technologically advanced than passenger windows. Pilots rely on clear visibility in extreme conditions, so cockpit windows are engineered to withstand bird strikes, heavy rain, hail, and severe temperature variations. Many cockpit windows contain built-in heating elements. These transparent heating systems prevent ice and fog formation during high-altitude operations. Without these heating systems, visibility could become dangerously reduced during flight. Cockpit windows undergo rigorous impact testing before certification. Interestingly, window seats remain the most preferred seats for many travelers because they provide scenic aerial views and privacy during flights. Another interesting fact is that window seats are often preferred by passengers because they provide scenic views and a place to rest during flights. However, aviation engineers view windows very differently as highly critical structural components essential for flight safety. So, while passengers enjoy beautiful cloud views and sunsets from their seats, aircraft windows silently perform one of the most important safety functions in aviation. They protect passengers from extreme environmental conditions while allowing humanity to experience the wonder of flight thousands of feet above the Earth. One interesting feature found in aircraft windows is the tiny hole located near the bottom of the window. This is called the breather hole or bleed hole. Although it may look insignificant, it performs a critical role. The breather hole helps equalize pressure between the inner and middle panes, ensuring that the outer pane carries most of the pressure load. It also prevents window fogging and moisture buildup. One interesting fact is that airplane windows can experience thousands of pressure cycles during their lifetime. Every takeoff and landing creates a complete pressurization cycle that stresses the window structure. Many passengers notice frost or fog around the edges of aircraft windows during flight. This occurs because the outer pane becomes extremely cold while the cabin remains warm. On some modern long-haul aircraft, electronically dimmable windows have replaced traditional pull-down shades. This technology allows passengers to darken windows gradually while still enjoying outside visibility. Some modern aircraft, like the Boeing 787 Dreamliner, use electronically dimmable windows instead of traditional window shades. Passengers can adjust the window darkness using electronic controls, improving cabin comfort and reducing heat inside the aircraft. Instead of traditional shades, these windows use electro-chromic technology, where electric current changes the opacity of the glass, allowing passengers to control brightness while reducing cabin heat and UV radiation. So the next time you look through an airplane window, remember that it is far more than just a viewing panel. It is a highly engineered safety system designed to protect passengers while allowing humanity to experience the beauty of flight high above the Earth.